Welcome to Ask and Learn.
We are given the definition of the Lucas numbers and initial conditions for the Lucas numbers. We are asked to answer some questions about them. So they satisfy the recurrence relation ln equals ln minus 1 plus ln minus 2, and the initial conditions L0 equals 2 and L1 equals 1. In part A, we're asked to write the Lucas number ln in terms of the nth and in terms of the n minus first and n plus first Fibonacci numbers. So in this case, we'll use induction. So if n is equal to 2, we have that L2, this is equal to, from the definition of the Lucas numbers, L1 plus L0, which is 3. And we have that F1 plus F3, this is going to be 1 plus 2, which is also 3, so that it works for the base case. And for the inductive step, we're going to suppose that the Lucas number ln is equal to fn minus 1 plus fn plus 1 for all n less than or equal to k for some k which is going to be greater than or equal to 2. And this is going to be all n between 2 and k. So we have that L sub k plus 1 by the recurrence relation is Lk plus Lk minus 1. And by the inductive hypothesis, this is equal to Fk minus 1 plus Fk plus 1, which is equal to, or plus, and this is Fk minus 2 plus Fk. And this can be rewritten as Fk minus 2 plus Fk minus 1 plus Fk plus Fk plus 1. And we have, by the recurrence relation for the Fibonacci numbers, that this is equal to Fk plus Fk plus 2. And this is what we wanted to show. So it follows that ln is equal to fn minus 1 plus fn plus 1 for all natural numbers greater than or equal to 2 by induction. And in part B, we're asked to find an explicit formula for the Lucas numbers. So we have that the Lucas numbers have a linear homogeneous recurrence relation, and so the characteristic equation is r squared minus r minus 1 equals 0, which has roots r equals 1 plus or minus the square root of 1 plus 4, which is 5, all over 2. And these roots are distinct, so it follows that the general solution is ln equals alpha 1 times 1 plus root 5 over 2 plus alpha 2 times 1 minus root 5 over 2. And from our initial conditions, we have that 2 is equal to, and these are both the n, alpha 1 plus alpha 2, and we have that 1 is equal to 1 plus root 5 over 2 alpha 1 plus 1 minus root 5 over 2 alpha 2. To simplify, subtract 1 minus root 5 over 2 of equation 1 from equation 2. So we get 1 minus 2 times 1 minus root 5 over 2 is equal to, this is going to be alpha 1 times 1 plus root 5 over 2 minus 1 minus root 5 over 2. And so we get on the left-hand side, this is equal to 1 minus root 5, which is simply root 5. And on the right-hand side, we have 1 minus 1 is 0, root 5 minus negative root 5 is 2 root 5. So alpha 1 root 5, so that alpha 1 is simply equal to 1. And by back substitution, we have that alpha 2 is equal to 1. And so the particular solution is ln equals 1 plus root 5 over 2 to the n plus 1 minus root 5 over 2 to the n.